everyone, this is Miss Faina. I'm back with another video for our trigonometry unit. This video is going to be on reference angles. So to get started, we have some key definitions. Now, if at any point you need to write anything down, please pause the video so you can write it down. So an angle that is in standard position is when its vertex is at the origin. Okay, a vertex is where our two rays are going to meet. So the origin's right here at the center. Okay, that is our origin. So the initial side of the angle is the one that makes with the x-axis. So the initial side is right here on both of these diagrams. Okay, that's the initial side in blue. The other ray is called the terminal side. Okay, again, a ray is where you have one ending point and it goes off in one direction. So I have an end point in one direction. Okay, that is the terminal side. So just some definitions for you. Now, we need to talk about angle rotation. So this is formed by rotating the terminal side and keeping the initial side in place. Again, the initial side is the one that is at the x-axis. So my initial side is staying on this x-axis. My initial side is staying on this x-axis. Okay, now we have two different types of rotations. We can go clockwise or counterclockwise. If we are going counterclockwise, so let's say I have an angle that is over here, and my rotation goes counterclockwise. That's backwards from a normal clock. Okay, it's going counterclockwise. This is a positive angle for us. It's a positive rotation. Okay, my terminal side is this one right here. So this is the terminal side. I'm just going to call it term, abbreviate it. And my initial side, the starting point, is right here, the blue. Okay, now, if our angle happens to go down or clockwise, that is a negative angle rotation. Okay, it's going in the negative direction as far as angles go. Again, I have my terminal side, and I have my initial side. Okay, my initial side stays on the positive x-axis. So we're going to practice drawing some of these angles out, understanding what the angle measurements are. Okay, so first off, we want to draw 320 degrees. Well, what we need to understand that if I go up 1/4 of the way, that's only 90 degrees. If I go halfway around, that should be 180 degrees. If I go 3/4 of the way around, that's 270. And if I make one full rotation counterclockwise, that's 360 degrees. And I start, of course, at 0 degrees. So 0 and 360 degrees are in the same spot. So if I'm wanting 320, that means it needs to be greater than 270, but less than 360. So I'm going to draw an angle right here, and I'm going to show my rotation. So it starts with the x-axis, and it goes all the way around here, and this is going to be our 320 degrees. Okay, looking at letter B, notice it's a negative angle, negative 110 degrees. So this means we are going to go clockwise. Okay, so if I'm going clockwise, I have to think backwards. So I'm starting at 0, and if I go down in the negative direction, that's a negative 90 degrees. If I go halfway around, that's a negative 180 degrees. And if I go 3/4 going clockwise, that's a negative 270 degrees. Well, I'm wanting a negative 110, which means it's going to be between negative 90 and negative 180, or to say it properly, between negative 180 and negative 90. Okay, it's going to be a little closer to the negative 90, so it's going to be right here, and I have to make sure that I show it going clockwise. So I start at the x-axis and it goes right here, so that's a negative 110 degrees. Okay, now looking at letter C. we have 990 degrees. I want you to take a second to see if you can draw this out. Okay, so I gave you some time to draw it out. Let's see what you did. Now, this one is going to be more than one full rotation because one full rotation is 360. So keep that in mind. So I'm going to go ahead and draw out. I have 90 degrees, I have 180, I have 270, and I'm just adding 90 every time, and I have 360. If I make a second rotation, this is now 450 degrees. This turns out to be 540 degrees. This is 630 degrees, and this one is 720 degrees. So I'm doing 2 full rotations now. Okay, if I go around again by adding 90, this turns out to be 810. This one turns out to be 900. And this one right here would be 990, which that's the angle we're looking for. So I have 1 full rotation. That gives me 360, and I'm going counterclockwise because it's positive. Then I have a second full rotation. That takes me to 720. And then I have 3/4 of rotation, and it stops right there, and that gives me that 990. Oops. There we go, degrees. Okay, now we're going to talk about reference angles. Okay, the reference angle for an angle, theta, is written as theta prime. This is a positive acute angle. Well, what is an acute angle? Okay, well, an acute angle is an angle that is less than 90 degrees. Okay, made with the terminal side, remember what the terminal side was, of the angle theta and the x-axis. Now, this can be any x-axis, positive or negative x-axis. We want whichever is closer. So what I'm talking about is if I have an angle that's over here, I want to use this negative x-axis right here because this is going to be that acute angle. Okay? Versus if I have an angle in the 4th quadrant, so I have an angle over here, I want to use the positive x-axis to make that acute angle. Okay, now theta is going to be the angle that's given. So this is theta, this is our given angle. And theta prime is going to be our reference angle. Okay, so just some terminology for us on this. So let's put this to use. Now, I'm going to break it down by quadrant because I think that what makes most sense. So for quadrant 1, this is the important part right here. Quadrant 1. Anything in quadrant 1 is already an acute angle. It's between 0 and 90. So theta prime, which is our reference angle, is going to equal our given angle because it's in the 1st quadrant. So find the measure of the reference angle given the angle. Again, because I'm given this is my theta. Oops, let me change my colors. There we go. Because I'm given this as theta, my theta prime is going to equal the same thing. Okay, so to kind of show you what this looks like on a graph is I have an angle 32 degrees right here. I want to know what it makes with the x-axis. So this is the same thing. So it's going to be the same no matter what it is in quadrant 1. Okay, so letter B, 45 degrees, that is our theta. So my theta prime is also 45 degrees. So I want you to take a second and figure out letter C. Okay, letter C, we were given theta as 89 degrees, so my theta prime is also 89 degrees. Okay, so that only works for quadrant 1. Now, when we are in quadrant 2, we have to subtract our given angle from 180. We have to subtract our given angle from 180. Okay, because we want the closest x-axis and it has to be an acute angle. 93 degrees is not an acute angle. We have to make it acute. So I take, this is my theta. I take, to get theta prime, I have 180 minus 93. So in my calculator, I type in 180 minus 93, and theta prime equals 87 degrees, and that fits the description of an acute angle. So in a picture form, 93 degrees is going to be a little more than 90. So that's this right here. The reference angle that we're talking about is the one that it makes with the x-axis. So we're talking about from here to here, what I just changed to red. This is 83 or 87 degrees. That is the reference angle we're looking for. It's always whatever is the closest x-axis. So letter B, we're given theta to be 120. So I'm going to take 180 and I'm going to subtract 120 to get my theta prime. So theta prime, when I type that into my handy dandy calculator, I get 60 degrees. Okay, so what I want you to do is I want you to try letter C. Okay, letter C, you should have taken 180 degrees and subtracted 137. When you did that, you should have gotten 43 degrees. If you got that, good job. Okay, now that's only quadrant 2. Again, the highlighted part is the important part. So far we've talked about quadrant 1, where theta prime is exactly theta, and quadrant 2, theta prime equals 180 minus theta. Going into quadrant 3. Quadrant 3, now we're going to take the angle we're given, theta, and subtract 180 from it. Okay? Because these numbers are going to be greater than 180, but 180 is still the closest x-axis. Okay, and we want it to be positive and acute. So, I have theta prime is equal to 210 minus 180. 210 minus 180, that gives me 30 degrees. Okay, so just to show you a visual representation of what we're talking about, I had an angle that was out here. Okay, this whole angle, I'm going to do it in red, the whole angle is 210 degrees, but we want it to be positive and acute, so we want to know what it forms with the x-axis. So here's the x-axis, and we're just talking this little chunk right here. That is what is 30 degrees. That is our reference angle. Okay, so looking at letter B, I have 240 degrees, so I take, to get theta prime, I take the given angle and I subtract 180 from it. When I do that, I get 60 degrees for theta prime. Okay, so I want you to take a second and solve for letter C. Okay, so what you should have done, you should have got theta prime equals 228 minus 180. And when you do that, theta prime should equal 48 degrees. Okay, and our last little bit is quadrant 4. Okay, quadrant 4, when it's in quadrant 4, now we're going to take 360 degrees and subtract theta from it. Okay, the x-axis that's closest to it, oops, so the x-axis that's closest to it would be this one right here, and it would be one full rotation around. That's why we're doing 360 degrees. Okay, now I did forget to tell you about the quadrant, so in case you forgot, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this one right here is quadrant 4. Okay, and I use Roman numerals. You do not have to use Roman numerals. Okay, so from this one, we're going to take 360 degrees and subtract theta from it. So I have theta prime is equal to 360 degrees minus 315. When we do that, we get theta prime to be 45 degrees. And yes, that's an acute angle. Just to have a reference of what this looks like. Right now, 315 degrees would be somewhere around here, and it's all of that rotation. But we want to know what it makes with the x-axis. So we're looking for this little chunk right here, and that is the 45 degrees. Okay. Looking at the next one, we have 285. So I take 360 minus 200. That's not a 200. Minus 285. And when I subtract those, I get 75 degrees. Okay, so I want you to take a second and solve for letter C. Okay, so when you did this, you should have taken 360 minus 345. And when we subtract those, you should have gotten a 15 degrees for the reference angle. Okay, so I hope this video helped you understand reference angles. Definitely do the practice. The more practice you get, the better off you will be. If you have any questions, please contact your teacher during their office hours.